So let's try the first question over here. Okay. Now, so we have a electrochemical cell. Okay, it's going to be constructed using two half cells. Okay. So you have this. They want you to find out the material used for the electrode. Now you can see roughly now. Okay, when they ask questions on electrochemistry, they are asking you what type of electrode that is being used. Okay. So you can see in this half cell. Okay, if there is going to be both aqueous, then the only electrode that we use is going to be platinum. Okay, so please take note of that. And then when you have aqueous and metal, okay, cell, then the electrode that we need to use is going to be the metal itself, which is going to be the aluminium. Now, if they have used, for example, aqueous and gas, okay, aqueous and gas, for example, H2 and then H plus, for example, again, okay, the electrode that we are going to use is going to be platinum. Okay, please take note of this. I don't think so they will ask you why. Okay, but if they ask you why, then you just tell that platinum is inert and it is able to conduct electricity better, something like that. Okay, that will be the best answer. Now, the cell is operated at a standard condition. Okay, and then aluminium half cell also standard condition. And they have mentioned that this, okay, SN4 plus is 0.3, and this is going to be SN2 plus is 0.15. So basically they are not in a standard condition. Now, if you are going to use, if you are going to calculate the electrode potential where they are not in standard condition, then we use the Nernst equation. Now, this Nernst equation, in the past, okay, what we have done, we ignore the reduced form, okay, because why? The reduced form is going to be the metal. Okay, I hope you can recall all this. Okay, if I have, like, for example, copper 2 plus plus 2 electron to become copper, I am only going to use the concentration of copper 2 plus. That's going to be the oxidized form. Now, it is very important to find out which one is oxidized form, which one is going to be reduced form. So here, when you look at plus electron, anything that is going to be plus electron, you see oil rig. Okay, reduction is going to be gaining of electron. So this is going to be reduced. So this is going to be the copper is going to be the reduced form. Okay, please remember. So copper 2 plus is being reduced and copper is the reduced form. And that's why copper is not included if we use Nernst form, because copper is metal. There's no point of looking for the concentration of copper. So that's why we just say log oxidized form. Okay, but here we have to include oxidized and reduced because both of them, okay, are ions. Okay, they are ions. So here, okay, use the Nernst equation. I think you just make sure you know the equation, the Nernst equation. Okay, the E standard, okay, 0.059 divided by Z, which is going to be the charge. Okay, in this case, there are 2 electrons being used, so this is going to be 2. Yeah, so please take note. Log oxidized form divided by reduced form. So you need to know which one is going to be oxidized form, which one is reduced form. In that sense, you need to write down SN4 plus, SN2 plus. Okay, so this is going to be plus 2 electron to give you SN2 plus. And you can see that this is going to be adding electron. So it's going to be gaining electron. This has been reduced. The SN4 plus is reduced to become SN2 plus. So this is the reduced form. Okay, please take note. SN2 plus is the reduced form. So therefore, okay, when I use the reduced form, okay, this one will be 0.15, and this is going to be the oxidized form is 0.3. That's why you get 0.3 divided by 0.15 log 2. Why this thing is going to be very important? Because students tend to think like this. They think, oh, SN4 plus plus 2 electron, this is going to be reduced. Also, this is going to be reduced form. Wrong. Okay, please take note of this very carefully. So once you do that, okay, when you calculate, you will get positive 0.16. Now calculate the E cell, very easy also. Okay, look at your data booklet. Okay, you will see the negative 1.66, 0.15. The one that is more positive will move forward. This is moving forward. This will move backward. Okay, so this will be 0.15. That one that goes backward is going to become plus 1.66. So the E cell you just need to add. Okay, when you add, you are going to get positive 1.82. Okay, very easy this part. And then writing the equation for the overall cell, yes, based on how you calculate, this is going to go forward, this is going to go backward. Balance the electrons, okay, balance the electrons, okay, and then you cancel the electrons and you will get this. Okay, quite easy. Okay, quite easy to get this answer. Okay, but what is going to be a bit difficult is this part. Yeah, please take note of this equation, Nernst equation. And I'm trying to relate with the metal, because in the past year papers, in the previous questions, we always have been dealing with copper and copper 2 plus or any kind of metal. Okay, so we always use this form. Okay, E equals to E like this, and then plus 0.059 divided by Z. Then we put log, and then straight away the ion that is available, okay, which is the oxidized form. Okay, but they will always tell, okay, this is going to be the amount of copper or something, but we don't actually look into the copper. We only use the copper 2 plus. Why? Because it's going to be the oxidized form. The reduced form is the metal. They are going to be constant concentration. We don't include them. Okay, but now it's going to be slightly different, which is important as well. Okay, please take note. Now, aluminium is produced industrially by electrolysis of melt containing large amount of aluminium ions. Okay, so this one is going to be Al3 plus 3 electron to give you Al. Calculate the mass of aluminium that is obtained. Okay, this one is quite easy here. Q equals to IT. So 300,000. Okay, time, okay, must be in seconds. Okay, 24 hours, change it into minutes. Okay, and then after that, change it into seconds. Okay, you calculate this and you will get, okay, let me calculate. (2.592) times 10 to the power of 10, okay, column. And we know that, okay, according to the equation, 3 Faraday can form, okay, 1 mole of aluminium. 3 Faraday is 3 times 9, 6, 500. Okay, you should remember this already. Okay, we'll form 1 mole. So 3 times that, 289,500, 1 mole. So if it is going to be 1 column, 1 divided by 289,500, I want to calculate for this. So times only. So I'm going to have 1,289,500 times 2.592 times 10 to the power of 10 moles. Okay, if you calculate that, (89533.68 mole). Okay, then you need to change it into mass. Okay, so aluminium. Okay, the AR for aluminium, you need to find out. Aluminium is 27. Okay, so N equals to M over AR. Okay, M is going to be just times 89533. This is going to be in gram, 2417409.326 gram. So if you want to change it into kilogram, maybe 2417.4 kilogram, if you want to leave it like that. Okay, let me check the answer key. Two four two zero. Okay, they change it into three significant figures. Okay, but there is no mark deduction. Okay, if you don't change it. Okay, so three significant figures. Okay. Oh, they mentioned over here. I missed this. Yeah. So they mentioned it must be three significant figures. Okay. So cannot leave it like this. Okay. 2420. Okay, kilogram. Now explain why chromium metal cannot be obtained, okay, by electrolysis. Let's finish this. Now, chromium, if you look at your data booklet, you are going to get negative 0.91. And then here, when you do electrolysis, dilute aqueous chromium sulfate. I think this is IGCSE also. Sulfate, okay, you cannot electrolyze, okay, it's a very big ion. So what happened is going to be, if you're using chromium metal, okay, the only thing that will go and attracted to the cathode, okay, the cathode, sorry, the one that will be attracted to the anode, okay, will be the anion. It's not the sulfate ion. It's going to be the, hold on, it's going to be why chromium metal cannot be obtained, okay, by electrolysis. So if it is going to be Cr3 plus, okay, plus 3 electron, okay, and then dilute aqueous chromium sulfate, okay, so we are going to use chromium ion, okay, and another thing that we are going to use is not the sulfate, we are going to use the hydrogen ion, okay. So why chromium metal cannot be obtained by electrolysis of dilute aqueous chromium sulfate. So the dilute, okay, the dilute over there is going to be, we need, okay, we need a positive ions over there. So we need the positive ions that we need, okay, is going to be the H plus. So we want to find out, okay, whether you are going to get chromium metal, okay, or whether you're going to get something else. So when I use this, okay, what is going to happen is I know this is all at the cathode, yeah. So I know what's going to happen. Basically, when you have the Cr3 plus, you have you can see this is more positive. Okay, so this will go to the forward direction, and this will go to the backward direction. So it means you are going to use up the chromium metal, not forming the chromium. Okay, so how do I explain over here? Okay, you can say that hydrogen gas is formed. Okay, hydrogen gas is formed, and tell why. Okay, because the E cell, okay, is more positive. Okay, and chromium metal will be used up, or chromium metal is going to be chromium metal is going to change to Cr3 plus, so it's going to be is oxidized. Okay, that will give you the 2 marks. Okay, refer to the marking key. The marking key is telling that, okay, please, they also ask you to write down the E cell, that is going to be the 1 mark. Okay, and then the moment you say hydrogen is formed, or hydrogen ions easier to reduce, or hydrogen has positive E cell, then it's enough already. Okay, so that's it for today. Okay, so is there any question?